Imagine a world where a single calculation could unravel the secrets of existence itself. A world where machines don't just crunch numbers, they tap into the very fabric of reality, harnessing the power of universes beyond our own. This isn't science fiction. This is the mind-bending reality of quantum computing, a revolution so profound it could redefine what it means to be human. In 2019, a tech giant shocked the world, claiming their quantum machine, a marvel named after a tree, performed a task in 200 seconds that would take the most powerful supercomputer 10,000 years. But that was just the beginning. Today, a new quantum titan has emerged, one that dwarfs its predecessor. This device, a next-generation wonder, can solve problems in under 5 minutes that would take a classical supercomputer 10 septillion years, a number so vast it stretches beyond the age of the universe itself. 10, followed by 25 zeros. Wrap your mind around that. This isn't just about speed, it's about something far deeper, something that challenges everything we thought we knew about reality. These machines, they say, aren't just computing in our world. They're reaching into parallel universes, calculating across realities we can't even see. How? Why? Buckle up, because we're diving into the wild, emotional, and utterly shocking truth behind quantum computers and their need for other universes. Let's start with the big question: how can a machine be so powerful? The answer lies in the strange, almost magical world of quantum physics. Picture this: an electron, the tiniest building block of matter, can exist in two places at once. It's not a glitch or a trick. It's reality at its most fundamental level. This bizarre behavior, where particles can be in multiple states simultaneously, is called superposition. It's as if the universe itself is playing a cosmic game of probability, refusing to pick a side until forced to. Now imagine a computer that doesn't just use ones and zeros like the devices on your desk. Instead, it uses quantum bits, qubits, that can be 1, 0, or both at the same time. This is the heart of quantum computing, and it's why these machines can process information at speeds that make classical computers look like abacuses. But here's where it gets wild. Some of the brightest minds in physics believe this incredible power comes from tapping into parallel universes. Yes, you heard that right. The multiverse, the idea that countless realities exist alongside our own, might be the key to unlocking the full potential of quantum computers. To understand this, let's take a step back and explore the foundations of quantum mechanics, the science that makes all this possible. Classical physics, the kind that explains why apples fall from trees or why planets orbit stars, works beautifully for the world we see around us. But when you zoom in to the subatomic level, things get weird. Particles don't behave like tiny marbles. They're fuzzy, unpredictable, and can exist in multiple states at once. A particle might be here, there, or somehow both, until you measure it. This is where classical physics breaks down, and quantum mechanics steps in to pick up the pieces. Quantum mechanics describes a universe that's less like a predictable machine and more like a cosmic lottery, where probabilities rule and certainty is an illusion. One of the most famous ideas in this field is a thought experiment involving a cat locked in a box with a radioactive atom, a vial of poison, and a mechanism that could kill the cat if the atom decays. Until you open the box, the cat is both alive and dead. A superposition of possibilities. It's only when you look that reality chooses one outcome. This paradox, bizarre as it sounds, captures the essence of quantum mechanics. The universe doesn't commit, to a single reality until it's forced to. But here's where things take a turn into the extraordinary. Not everyone agrees on what this means. Some physicists argue that when you measure a quantum system, like checking on that cat, you collapse all possibilities into one reality. This idea, known as the Copenhagen interpretation, suggests that the act of observation shapes the universe. But others, including some of the most visionary thinkers in the field, propose something far more radical: the many worlds interpretation. According to this theory, every quantum event, like measuring a particle or opening that box, splits reality into multiple universes. In one universe, the cat is alive. In another, it's dead. Every possibility happens, but in a separate reality. When you measure a particle's position, you're not collapsing anything. You're just seeing one version of a multiverse where every outcome exists. This isn't just a quirky idea. It's a serious scientific hypothesis that's gaining traction, and it's at the heart of why quantum computers might need other universes to work their magic. Now, let's bring this back to quantum computers. Unlike classical computers, which process information in a linear, step-by-step way, quantum computers use qubits that can exist in superposition. This allows them to explore countless possibilities at once, like a cosmic chess player considering every move on the board simultaneously. But where does this insane computational power come from? Here's the jaw-dropping claim. Quantum computers might be performing calculations across multiple universes. Imagine a problem so complex that solving it would take a classical computer longer than the universe has existed. A quantum computer, some argue, doesn't just solve it faster, it delegates parts of the calculation to parallel realities, each tackling a different piece of the puzzle. When the results come together, it's as if the computer has harnessed the processing power of countless universes, all working in unison. This idea, as wild as it sounds, isn't just a thought experiment. It's rooted in decades of research and some of the most groundbreaking experiments in physics. Let's talk about one of those experiments, a cornerstone of quantum mechanics that's as mind-blowing today as it was a century ago. The double-slit experiment. Picture a setup where you fire photons, tiny packets of light, at a barrier with two narrow slits. Behind the barrier is a screen that records where the photons land. If photons were just particles, you would expect them to pass through one slit or the other, creating two neat bands on the screen. But that's not what happens. Instead, the photons create a pattern of alternating bright and dark bands, as if each one passed through both slits at once, interfering with itself like a wave. This is shocking enough, but it gets crazier. If you fire photons one at a time, they still form this interference pattern over time, as if each photon is somehow aware of both slits. Now add more slits, say 4, and the pattern changes in ways that defy common sense. A spot that was bright with 2 slits might go dark with 4, even though you've added more paths for the light to travel. It's as if something invisible is interfering with the photons, something that only exists when certain slits are open. This something is what makes the double-slit experiment so profound. Visionary physicists have argued that the interference patterns we see are evidence of parallel universes at work. When a photon passes through one slit, its counterparts in other universes pass through the others, creating interference that shapes the pattern on the screen. These counterparts, call them shadow particles, are real, but we can't detect them directly. They exist in parallel realities, influencing our universe through quantum interference. This isn't just a theory, it's a phenomenon we can measure in labs. And it's not limited to light. Electrons, atoms, even molecules behave this way, suggesting that the particles making up you, me, and everything around us are constantly interacting with their counterparts in other universes. If this is true, then the multiverse isn't some abstract concept. It's woven into the fabric of reality itself, and quantum computers might be our first glimpse into its power. Let's zoom in on quantum computers again, because this is where the multiverse idea gets practical. A qubit in superposition isn't just a fancy bit, it's a gateway to exponential possibilities. A single qubit can represent two states at once. Two qubits can represent four. Three can represent eight. By the time you get to 300 qubits, you're dealing with more states than there are atoms in the observable universe. No classical computer could ever store or process that much information. Yet quantum computers handle it with ease, solving problems that would cripple even the most advanced supercomputers. For example, there's an algorithm that can factor large numbers exponentially faster than any classical method. A breakthrough with massive implications for cryptography, where secure systems rely on the difficulty of factoring. The question is, how can a quantum computer perform calculations that seem to require more resources than exist in our universe? The simplest answer, some physicists argue, is that it's not limited to our universe. It's computing across the multiverse, leveraging the infinite possibilities of parallel realities. This brings us to the latest quantum marvel, a chip so advanced it's rewriting the rules of what's possible. This device, a superconducting quantum processor, isn't just a step forward, it's a leap into the unknown. In a benchmark test, it completed a task in under 5 minutes that would take a classical supercomputer 10 septillion years. That's not a typo. 10 followed by 25 zeros. To put that in perspective, the universe is about 13.8 billion years old. This chip is solving problems on a time scale that makes the history of existence look like a fleeting moment. And it's not just about raw power. This chip is pushing the boundaries of quantum supremacy, the point where quantum computers outperform classical ones in ways that were once thought impossible. Its predecessor made headlines in 2019. But this new titan takes things to a whole new level, doubling down on the exponential growth of quantum technology. If the 2019 machine was a glimpse of the future, this chip is a screaming announcement that the future is here, and it's stranger than we ever imagined. But let's pause and ask, what does this mean for us? If quantum computers are tapping into parallel universes, what are the implications for reality itself? This is where things get emotional, because the multiverse isn't just a scientific curiosity, it's a profound challenge to how we see ourselves. If every quantum event splits reality into countless versions, then every choice, every action, every moment creates a new universe. There's a version of you that took a different path, made a different decision, lived a different life. These versions aren't just possibilities, they're real, existing in parallel realities that are forever out of reach. The idea is both thrilling and heartbreaking. It means every mistake, every triumph, every missed opportunity is playing out somewhere, in a universe where things turned out differently. It's a reminder of how fragile and precious our reality is, shaped by the choices we make and the chances we take. This idea also raises deep philosophical questions. If every possibility exists, What does free will mean? Are we truly in control, or are we just passengers in one of countless realities, each dictated by quantum chance? Some argue that free will is intact, because in our universe, we experience the consequences of our actions as if they were the only reality. Others say the multiverse makes free will an illusion, since every outcome happens somewhere. It's a debate that cuts to the core of what it means to be human, and it's one we're only beginning to grapple with. Yet beyond philosophy, there's a practical side to this. Quantum interference, the phenomenon that hints at parallel universes, has real-world applications. It's what makes quantum computers so powerful, allowing them to solve problems in cryptography, drug discovery, climate modeling, and artificial intelligence that were once thought unsolvable. In a way, the multiverse is already shaping our future, even if we can't see it directly. Let's dive deeper into the science, because the evidence for the multiverse is stronger than you might think. Beyond the double-slit experiment, there's another phenomenon that supports this idea: quantum entanglement. When two particles become entangled, their states are linked, no matter how far apart they are. Measure one, and the other instantly reflects that measurement, as if they're communicating faster than light. This spooky action at a distance, as it was once called, baffled even the greatest minds in physics. But the many worlds interpretation offers a way to understand it. Entangled particles aren't communicating. They're part of the same quantum system, split across multiple universes. When you measure one, you're aligning with a specific reality, and the other particle's state reflects that. Experiments have confirmed entanglement over distances of hundreds of miles, and it's a cornerstone of quantum technologies like secure communication and quantum computing. Every time we observe entanglement, we're seeing a glimpse of the multiverse at work. Now let's talk about quantum decoherence, the reason we don't see quantum weirdness in everyday life. When a quantum system interacts with its environment, say a particle bumps into air molecules, it loses its superposition and starts behaving classically. This is why you don't see cats in boxes being both alive and dead, or people popping up in two places at once. Decoherence is like a cosmic sensor, hiding the quantum world from our macroscopic reality. But quantum computers fight against decoherence, keeping qubits in superposition long enough to perform calculations. This is no small feat. It requires ultra-cold temperatures, near absolute zero, and shielding from even the tiniest vibrations. The fact that we can control decoherence at all is a testament to human ingenuity, and it's what makes quantum computing possible. Without it, we'd never be able to tap into the multiverse's computational power. Speaking of power, let's explore what quantum computers could do for humanity. Beyond breaking encryption, they could revolutionize medicine by simulating complex molecules, leading to new drugs and treatments. They could optimize global logistics, reducing energy use and combating climate change. They could even accelerate artificial intelligence, creating systems that think and learn in ways we can't yet imagine. But with great power comes great responsibility. If quantum computers can crack the codes that secure our digital world, they could disrupt economies, governments, and societies. The race to build these machines isn't just about science, it's about who controls the future. And if the multiverse is real, that future might be more complex than we can comprehend, with implications that stretch across realities we'll never see. Let's take a moment to reflect on the human side of this. The physicists who pioneered quantum mechanics, Giants who reshaped our understanding of the universe were driven by curiosity, wonder, and a relentless desire to know. They faced skepticism, doubt, and even ridicule, yet they pressed on, unraveling mysteries that seemed impossible. Today's quantum engineers carry that same torch, building machines that push the boundaries of what's possible. But this isn't just about scientists in labs, it's about all of us. Quantum computing could touch every aspect of our lives, from the medicines we take to the way we communicate. It's a reminder that the universe is vast, strange, and full of possibilities, and we're just beginning to explore it. The idea that our computers might be reaching into other universes is both humbling and exhilarating. It makes you wonder, what else is out there waiting to be discovered? Now let's address a question that's probably on your mind. Can we ever interact with these parallel universes? Pop culture loves the idea of jumping between realities, meeting alternate versions of ourselves, or rewriting history. But the truth is, there's no known way to physically travel between universes. According to the many worlds interpretation, each universe evolves independently, separated by a quantum divide we can't cross. You can't send a message to another version of yourself or visit a reality where things turned out differently. But that doesn't mean the multiverse is irrelevant. Through quantum interference, universes influence each other in subtle ways, shaping the outcomes we observe. Every time a quantum computer solves a problem, it's potentially leveraging these interference effects, drawing on the multiverse to achieve what no classical machine could. In a sense, we're already interacting with parallel realities. We just don't experience it directly. This brings us to a deeper question. Who are we in the multiverse? If there are countless versions of you, each living a different life, what makes you, you? Some physicists compare it to identical twins, genetically the same, but shaped by different experiences. Your counterparts in other universes started as identical copies, but diverged as quantum events unfolded. They're you, yet they're not. It's a concept that's both beautiful and unsettling, reminding us that identity is tied to the specific path we take through the multiverse. Yet, even if we can't meet these other selves, their existence shapes our reality through interference, entanglement, and the computational power of quantum machines. The multiverse isn't just a backdrop, it's an active player in the drama of existence. As we near the end of this journey, let's consider the future. Quantum computing is still in its infancy, but it's advancing at a breakneck pace. The chip that stunned the world with its 10 septillion-year benchmark is just the beginning. Researchers are already working on larger, more stable quantum systems capable of solving even harder problems. Some predict that within a decade, quantum computers could transform industries, from healthcare to finance to artificial intelligence. But the real transformation might be philosophical. The multiverse challenges us to rethink reality, free will, and our place in the cosmos. It's a call to embrace the unknown, to question everything, and to keep exploring. Because if quantum computers are teaching us anything, it's that the universe is far stranger and far more wondrous than we ever imagined. So where do we go from here? The truth is, we're standing at the edge of a revolution, one that could change the world as profoundly as the invention of the steam engine or the internet. Quantum computers, with their potential to tap into the multiverse, are more than just machines. They're a window into the deepest mysteries of existence. They're a reminder that reality is bigger than we can fathom, and that human curiosity, ingenuity, and passion can unlock its secrets. As we push forward, let's hold on to that sense of wonder. Let's keep asking questions, chasing answers, and dreaming of what's possible. Because in a multiverse of infinite realities, the only limit is our imagination. This is the dawn of a new era, and it's going to be absolutely breathtakingly, universe-shatteringly incredible.